This is section 1.5, combinations of functions. So we're going to talk about arithmetic combinations, finding the sum, difference, product, or quotient. And then we're going to talk about composition of functions, which is a little bit different. So to find the sum of f plus g of x, it's the same thing as adding the f function plus the g function. If we're doing the difference, we're subtracting the two. If we're finding the product, we're multiplying. And if we're finding the quotient, we're dividing. So anytime you see this, it means this. Add the two functions together. So it's just getting used to this notation of what it looks like. What is this asking me to do? So for a couple examples, we start off with addition, f plus g of x. So from above, we know that f plus g of x is the same thing as f of x plus g of x. So when we solve for this, we're going to take the f function, which is 2x minus 1, and we're going to add to it the g function. So I put that second function in parentheses because let's say this was a minus sign, you would want to distribute to the entire function. It's addition, so when we distribute that, it doesn't change anything, but it's just good to get in the habit. So once we get over here to this example, subtraction, you remember to distribute. So now we're going to combine like terms. So 2x minus x gives us 1x. Negative 1 plus 1 gives us 0. So x is our final answer for f plus g of x. If we look over here at subtraction, we're going to do the same thing because f minus g of x is the same thing as f of x minus g of x. And we get that from our definitions right at the top. So right up here, our difference. So now we are going to plug in what f of x and g of x are. Keep in mind, g of x should be in parentheses because we want to distribute that negative to everything. So first step, distribute the negative. 2x minus 1 plus x. Be what we get from that. And now we can combine like terms. So 2x plus x gives me 3x, and minus 1 gives me minus 2. And this would be our final answer for f minus g of x. So now if we get to multiplication down here, we get f times g of x. This is the same thing as multiplying f of x times g of x. So we're going to do that by taking the f function to x minus 1 and multiplying it by the g function, 1 minus x. Now to do this, we definitely want to FOIL. And here we get 2x. For our first, for our outside, we get minus 2x squared because x times x is x squared, and we have the 2 in front. And then we do our inside. Negative 1 times 1 is negative 1. And then we do our last. So negative 1 times negative x is positive x. And then we're going to combine like terms. So we have a 2x in front and we have an x here. That gives us 3x. And we can put the x squared first just to keep things in order. And that would be my final answer. For f over g of x, we're going to divide them because this equals f of x divided by g of x. So f of x is 2x minus 1 over g of x is 1 minus x. Now, in this case, there is nothing to simplify. We cannot cancel out these x's because we have to think of this as an entire factor in itself. So unless you see an entire 2x minus 1 on the bottom or an entire 1 minus x on the top, you cannot cancel these things out. So the last thing I'm going to talk about is composition of functions, and it looks like this. So this isn't saying fog, this is saying f of g of x, and it looks like this. F of g of x. It's different than multiplying f times g of x. It's saying we're going to plug in the entire g of x function anywhere we see an x in the f function. So we're literally taking g of x and plugging it into the f function. So what that will look like is if we take our f function, which is 2x minus 1, and leave a parenthesis where the x is, we're going to fill the parenthesis with g of x, which is 1 minus x. And then we simplify. So first we'll distribute. We get 2 minus 2x minus 1. And when we combine like terms, 2 minus 1 is 1. So we get negative 2x, or plus 1, plus 1. So first, we write the f function with a parenthesis wherever there's an x, and then we fill it with the g function because we're putting g into the f function, and then we simplify as normal. We're going to do the opposite for this one. So now we're taking the g function, and anywhere there's an x, we are now going to fill it with the f function. So the g function is 1 minus x. So I'm going to leave a parenthesis, and I fill that parenthesis with f of x, 2x minus 1. Here I distribute the negative, so I get 1 minus 2x plus 1. And so my final answer when I combine like terms is 2x plus 2. The final thing that you might see is something like this, f plus g of 3 or f minus g of 2. And so instead of having an x, we're going to put a 3 in the f plus g of x function. So if we go up here, f plus g of x equaled x. So instead of this being an x, our final answer is now going to be 3. So you would go through, find f plus g of x, and then whatever that final answer is, plug this in for x. For f minus g of 2, if we go back up to the top, f minus g of x is 3x minus 2. So instead of x, if we want a 2 here, we can plug in a 2 to our final answer, and that will give us f minus g of 2. So 3 times 2 minus 1. Just make sure it was minus. Oh, it's minus 2. So 3 times 2 minus 2 gives us an answer. So we get 6 minus 2 equals 4. And for these, when we're plugging in a number, you should get a number as your final answer.